Good evening, it's Niall McGorn here from Lely Centre Mullingar, and you're very welcome to the 10th in our series of webinars looking at all aspects of robotic milking. You can see on the screen in front of you, we've covered a huge amount. There's a lot of information there for anyone who's any interest in farm automation or robotic milking, be it an indoor system, be it fully grazing, or a hybrid of a mix between the two. So there's a listen back facility. So anyone who's registered for any webinars, you should have had a link to allow you to watch all that content in your own time. If not, get in touch. I will quite happily send you on a link that will give you access. You can watch at your own convenience. So this evening, we're going to look at basic requirements for robotic milking installation. We did touch on aspects of this in the past, but we had an awful lot of questions and queries over the last couple of months. So we felt it's necessary maybe to go into a little bit more detail and cover what's involved and answer more questions maybe that we didn't cover in previous webinars. So you're all aware of the cover and the support that we offer. 15 full-time engineers, an engineer within half an hour of every customer. We invest hugely in support. We know when you have a robotic milking system that it's very important there's always someone there to deal with any situation that may arise. Never mind how infrequent it may be, but it gives our customers great confidence to know there's always someone there to help them if they do get in bother. And we're very well organised, so if anyone ever wishes to call in and see us in Mullingar, you're very welcome. We'll give you a tour and see our huge stock of parts and how we manage the system. This evening, we're going to be hearing from William Conlon and Seamus McDonough. William is going to give us a lot of detail around what's involved with a robotic milking installation. William is more involved in the design part of the process. So he sits down with the client after looking at the yard and tries to deal with the aspects of cow flow, automatic drafting, labour efficiency, trying to make use of the building that's there, or maybe even looking at a complete greenfield site. When the client has agreed with William on a plan, then the detail must be created, and then he hands over to, in this instance, Seamus McDonough. Seamus is our senior project coordinator. So what he would do then is go back and survey the site, look at the concept as designed by William, and create the drawings and the plans that are required for the tradesmen who are going to be doing the build, be that the shed man, concrete man, plumber, electrician. And Seamus then takes responsibility up until the first cow is milked. So he would also be working closely with our farm management support advisors who you heard from in previous webinars. He's also ably assisted by Mark O'Farrell, and Simon Moore, of course, is a key member of the team as a senior yard designer and a dairy farmer with 2 robots himself. So without any further fuss, I'm going to pass on to William, and I hope you find the rest of the presentation interesting. Over to you, William.
Okay, thanks, Niall. So my name is William Conlon and I work on the yard design side of things. So I'm just going to take you through briefly, I suppose, the design side of the build and I suppose what the project coordinator's role is when it comes to installing a Lely robot. So my first visit on the farmyard design side of things, I'm really trying to get a feel for the farm, the farmer, how machinery moves around the yard, how cows, if you're an existing farmer, how cows currently move around the yard. If you're a new entrant into dairy, how cows could potentially move around your yard. So you're looking then at what sheds are on the yard, what sheds you could tie in and convert over and use for cubicles and to put the robot into. Or alternatively, if there's no shed suitable, then where you would position a new greenfield build. So what you're really trying to achieve is trying to maximize cow flow throughout the yard to get to and from the robots. So you're depending on your cow to walk in from grass, be milked, go through the robot, go back out through the Grazeway gates and go back out to grass. And you're asking her to do this a couple of times a day. So the last thing you want to do is put any sort of blockage in her way that's going to slow her down or stop her getting to that robot. So it's all about trying to maximize cow flow and just give cows the options of going into the robot at ease. Like I said, we're looking at the area that's for development, whether it is existing sheds. I suppose a lot of the jobs, maybe 80% or more of the jobs we're involved with, you're trying to fit a robotic milking machine into an existing shed without compromising on the space around the robot, on separation areas, or any of the other aspects involved with robotic milking. So, you know, it is a balance to try and get everything into existing sheds, and that's what we put a lot of focus into. At the end of the day, it's all about keeping to within a budget for the farmer and keeping costs down when you're trying to get into the system. So if we look at an aerial view of this farm, the shed on the left there is a 4-bay slatted shed, a good lot of slats. There could be 3-4-bay tanks in that shed. So a good lot of slurry storage, good shed, leaves itself open to maybe fitting about 60 cubicles into, which was allow a farmer to get going, I suppose, without having to spend big money on trying to put up a new shed. So where the first red block in is where the first robot was installed. A year later, then the farmer installed the second robot and pushed on the numbers. Again, to start off, 2 banks of head-to-head cubicles were run down through the shed. To one side of the shed then we had our Grazeway. So this is, I suppose, what we'd call the dirtier side of the yard. So this is the side where cows are going to be coming in and out the whole time. So again, there's going to be a lot of cow traffic, a lot of movement over this area. So this is what we call our dirty side. On the other side of the yard then is what we'd have is our clean side. So we see here these 2 red arrows are where our A, B and C roadways out to paddocks would be. So then we look at the other side of the yard, what we call the clean side. So this is the side where your milk lorry is going to be coming in, where our service engineers are going to be coming into your robots, where you're going to be driving in and out with machinery, either with silage, where your meal lorry is going to be coming in. So this is the side there's going to be a lot of traffic. So we want to keep cows away from this, because I suppose it's different to if you were milking traditionally through a parlour. You can bring your cows in, lock them in, milk them, and work around the yard and then put them all out. Whereas with the robotic system, there's cows coming in and out entirely. So here we see our milk, where our milk tank is located. Our lorry comes in, picks up our milk, swings around and goes back out. We also have our milk coming across the yard underground in a duct over to our tank. So the robot and the milk tank don't need to be beside each other. The closer they are, obviously the better and the easier it is for an installation. But it's very manageable if there is a distance between the milk tank and the robot. In this case, it also helps that you're keeping the lorry out of the yard. He's not going in through the yard. He's not disrupting you when you're feeding silage or anything like that. He can work away at his own time. We see beside this again then, beside our dairy, we have an office and our compressor room. So again, they're just small areas that need to be fitted in, and in this case, just made the best use of the existing sheds. For this farmer, he didn't actually have to do any building of sheds to get going milking, which is a big bonus and a big help to keep costs down. So then outside of my role as kind of the farmyard design, we also look at what the lads do as kind of the project coordinators and what the benefit of them is to the project. So I bring the project up to a stage where we've agreed in the design. We're fully agreed in the design. That could take 3 or 4 visits depending on the farmer and what they want to do. And you might present a couple of different options to the farmer and see what they come back with. So when the full design is fully agreed upon, we hand over to a project coordinator. So I suppose the big benefit of having the 2 project coordinators is that they've installed 350 robots plus between them. So there's a great wealth of knowledge and experience of what's involved with an installation, how to liaise and how to work with builders to make sure everything is being done correctly, so that when we come to install the robot, there are no hiccups or no delays. So like I said, it leads to a reduced installation time when it comes to actually fitting the robot itself, because everything is done right. The robot can be put in, bolted down, and away you go. They give good guidance to keep the building costs of the project down. So, just because they have that much experience of the building work and what's involved, they can guide farmers as to what they should do and what they shouldn't do, and help keep a lid on costs. They produce detailed builder specification drawings that the builder is able to work off. So again, there's no confusion about where ducts need to be or what needs to be done. Along with this, they'll visit the site throughout the build and liaise with the builders, the plumbers, the electricians, the bulk tank provider, just to make sure every aspect of the project is moving along at the same stage. Because often when there's building work going on farms, it can be difficult for farmers, I suppose, to focus on all the areas and keep everything moving at the same time. So their job is really to keep the project on schedule and stick to the agreed upon installation date, whenever that may be set out, maybe 4 or 5, 6 months before the robot's installed. So then they deliver the project right up to the robot startup. So then that's where their job ends, and I suppose we hand over then really to the farm management support advisors who work with the farmers then from when you start milking moving forward to get the best out of your robot. If we're looking at installation times, I suppose we have a big benefit compared maybe to traditional milking systems, parlours, rotaries, whatever system it'd be, in that we could typically install a single robot in a Grazeway in 3 days. we'd run all the services, the milk line, the air line, the communication, the chemical line, and the water lines are all run when the first robot is put in. So it means that if we come back to add on a second robot, or third robot, or fourth robot, that you're just teeing off these lines that are already run, so it's a lot quicker of a process. You know, we could do installation jobs for 280, 300 cows in maybe a week and a half, which, you know, is a big difference to what some of the larger jobs on traditional systems could be. So I'm just going to look at very briefly a robot room. Seamus will look into this in more detail later, but it just kind of gives you a basis to what the different aspects are of it. So at the back, we have our separation buckets, drainage going across the room, base for the robot near the front of the room, the grate with the drainage sump where the cow will stand where she's being milked. And again, you're looking at certain heights and widths for the room. The only reason I show this is just, I suppose, to give you an idea of, I suppose, how little building work is required for an actual robot room. It can be very, very minimal. So then this is when the robots can be simply lifted into place. And the work here then goes from developing from this onto this image, which is the robot with the bar work completed around it. So that's what we do. That's what our engineers do, and you know, leave robots like that you're ready for startup. So there's no additional, you know, bar work that needs to be done in that area. Again, we're just going to look briefly what's above the robot. Again, very simple. You have the meal hopper and the auger. You have your milk line dropping down into the two robot rooms. You have your vacuum line, again, running to the two robots, and your airline communication and chemical lines. You also have your water. So this is all what we do. This is what the team at Lely Mullingar provide when we do an installation. Now the meal hopper and the auger, that's up to the farmer to sort out, but all the other lines is what we do. So then I suppose we've looked, the last job there was a two robot head-to-head system. For larger jobs, maybe 200 cows plus, we can see farmers going with a checkout system. So this is where the robots are put up in a line beside each other. I suppose there's positives and negatives to each system, which you can maybe see on earlier webinars. We talked through that. So we see here that the cows enter from one side of the robot, from this near side, and exit out onto a different area, the far side. So it just kind of keeps the pre-milking and post-milking cows separate, and can be a real benefit for cow flow when you have those, you know, 200 to 300, 400 cow herds going through robots. You can see as well that the four robots in this picture here, they still take up a relatively small footprint. So, you know, a few spans of a shed, and is a shed there that can milk 280 cows through four robots. So we see here on the right hand side, we have our two central units. So these act as the brains of the robot. This is where the chemical is pulled out of, where the water is heated for the robots as well. The next room then, we have robot 1 and 2 are inside in that room, and robot 3 and potential robot 4 in the far rooms. So we'll see again, this is your two central units, two cabinets. We have an area behind these where you can drop in big barrels of chemical. So trying to keep the labor side of things down. It's all trying to feed in to make the system run as simply and efficiently as possible for both the farmer and the cows. This is the inside then of the the first and second robots. So we'll see we have our milk for use buckets on the back wall. Again, this is where you can send either colostrum milk or waste milk to. And then we have the inside of our third robot is on the right hand side there in that picture. And we have the base already in place for a potential fourth robot down the line. So you're looking at an installation there of that fourth robot of maybe a day and a half. So it can be a very, very quick and efficient system. Outside the robot, I suppose the other key area is the Grazeway gates. So these are the drafting gates that work in conjunction with the robot. So we'd work a lot with the farm management support advisors as to where this should be located on the farm and the layout of it. So they generally walk the farm and will map the grazing block itself and decide where the roadways are going to be and how cows are coming back into the yard and exiting the yard. So I suppose they work from the Grazeway out towards the farm, out towards the land, and we generally work from the Grazeway back in towards the yard. So, you know, there's a lot of work over and back between the two teams to make sure cow flow isn't compromised when you're putting with the location of the Grazeway gates. So cows can be either sent to the A, B, or C grazing paddocks from the Grazeway gates. To get out of the yard, they have to go through this Grazeway gate, the red gate you can kind of see there in the picture. If the cow is due to be milked, she won't be let out through this gate, she'll be kept in the yard. But for cows to get back into the yard, they don't have to go through these gates. So every cow has free access to go back in through the one-way one-way Texas gates to get back into the yard to be milked. You also have the option to send cows to a local paddock from either the Grazeway or maybe from the robot. So this can be a small, maybe half an acre of paddock close to the yard, where you could send cows that are in heat, or a sick cow if you want to have a look at her, that you don't want her standing on concrete. So you'd see the real benefit maybe in May time. If you're bulling cows are automatically drafted off because of the automatic heat detection system that they have. And they can be just waiting in this paddock for when the AI man comes, bring them into the shed and AI them. They can get from this area back into the robot to be milked, but they'll only be let back out here again. Generally, your Grazeway gates are located on either a concrete slab or a slatted tank or maybe a flow channel. I suppose lately in the last couple of years, we've seen a lot more farmers who are putting in a slatted tank anyway because they're under pressure for slurry storage, and they're maybe running it out a bit further than the shed and having the Grazeway gates on it. But there's still probably half of the Grazeway gates that are on farm are sitting on a concrete slab. So here we have a relatively recent installation of a Grazeway on a slatted area. You can see the bit of a track there where cows are coming in, going out through the gate the whole time. So it can be an area that can get dirty. So the Grazeway, the tank underneath, just makes it an easier area to keep clean. Again, another Grazeway just sitting on top of a tank. So for suckler or beef men that are swapping over, a lot of farmers are going to use existing sheds to convert over to cubicles and to put the robot into. So, you know, by and large, we want to have our robot sitting just off a slatted tank, as it is a high traffic area. And this is an easy thing to incorporate in if we have a new build. But where there can be, I suppose, difficulty is if you have an existing build and the slatted tanks really aren't suiting the location where you want to put the robots, but you still have a good lot of slatted tanks that you don't want to go building slurry storage that you don't need. So I suppose you have the option of maybe going with the likes of a robotic scraper. So they can either be the standard Discovery, which is the one shown in the picture here, that'll just push slurry in front of it. So it'll push over solid area into a slatted tank, or you can go with the Discovery Collector. So what this does is it'll suck up slurry when it's on a solid area, and then when it gets to a slatted tank, it'll dump the slurry. So again, it can just provide a lot of options to farmers and maybe be more cost effective than having to turn around and build a slatted tank. So here we have a 2-robot installation where solid area in front of it, a lot of slatted tanks, and he's using a Discovery Collector to keep that area clean, you know, with 120 cows being milked. So it's doing a good job. Here we have another single robot farm. Again, not far from a slatted tank, but solid area in front of the robots. So went with a standard Discovery to push the slurry into the slatted tank, you know, a good few times a day to keep things clean. Just going to talk briefly on the TAMS grants that are available, because the deadline is the 21st of August to apply for this tranche. Now, there is another tranche opening up on the 22nd of August, but the amount of people that are applying for the TAMS grants is increasing. So if you are something you're thinking of doing, it is well worth putting in an application or giving us a call, and we'll maybe talk through with you a bit more of what's involved. A general applicant can get 32,000 in grant aid, and a young farmer can get about 48,000 in grant aid. And if farmers go into partnership together, they could get between 64 and 96,000 in grant aid. So it's a lot of money, and it's something that's still well worth looking into if you are thinking of going down the route. I suppose one of the benefits of a robot is that there's no planning permission needed if you are going down applying for a grant on a robot. So that brings to the end my portion of the presentation. So I just want to thanks for your attention, and if you have any questions, there's a chat function at the bottom of the screen where you can submit your questions and we'll answer them at the end. I'm going to hand over now to Seamus McDonough, who's one of the project coordinators. Thank you.
So good evening, everybody. Seamus McDonough is my name, and I'd just like to thank William for the introduction. So typically what we're looking at for a robot, the area of the robot room is about 12 foot wide by around 9 foot deep. So it's not a very big robot room or big area. So what's involved in it is walls, floors and drainage. So we produce a step-by-step guide to building a robot room. We also produce drawings. So there's probably about 5 or 6 different drawings, and the drawings go through the floor layouts. So the first drawing here shows wall layout. The second shows a cross section through walls with drainage underneath the robot. Our third one here would show cow flow. So just for better understanding for the builder, he can understand where cows are coming from, where they're milking in the robot, where they're going to. So it gives the builder a better understanding of what we're trying to achieve. The fourth one would show typically the foundations underneath the robot and the support. Fifth and sixth, again, are for the robot footing and for drainage. So here is a cow standing on the rubber mat. Now this image will help us understand the following photographs, and the photographs are made up just to allow the builder understand the different elements. So the cow is standing on a rubber mat. You can see between her legs and just underneath the clusters is a stainless steel grate. So the purpose of this grate is to keep her legs open and separated. This allows the cups to attach onto the udder, and it also takes away the dung from the rubber mat. In underneath the cow, we can see the floor of the robot room. So the operator stands inside in the robot room. Now, our next slide here, we can see the robot room ready for the robot to be placed in. So again, we can see the rubber mat, we can see the grate. So this stands outside of the robot room. The floor is finished here. You can see right across the center of the floor is an acre drain. So this is a plastic drain, and this takes all of the water and surface water away from the room. So what we do is we divert this in the drainage, and we divert it in through underneath the mat, and it helps clean out that sump area or that little manhole. On the back wall, you can see a red pipe. So on the back wall of the robot rooms is our in-for-use buckets. So we need to get the milk from the cow into the milk jar, and from the milk jar across through the concrete floor and to the back wall to the buckets. So our next slide here is some of the drainage underneath the concrete floor. So you can see an unlidded access junction or unlidded AJ, and this is how we get the milk across the floor. You can see it goes under the drain and it goes over to the back wall. So this is poured inside in the floor screed. Again, the second slide just gives you it from a different angle. Here is underneath the grate is the manhole I was talking about. So this is where the cow will dung into, and then it's taken away in the 4-inch pipe. The other two concrete pads, one of them is an L shape there, and the other one is a slender pad. It's about 3 foot long and maybe 6 inches wide. So this is where the robot is bolted to, and this is where the robot takes the weight. Here again, we can see the rubber mat and the grate, as I was explaining earlier. And if we have a more wide angle, we can see the rubber mat, we can see the footprint that the robot is bolted to, and this is just before our final concrete finish goes on. Again, developed on, you can see the mat and you can see the final floor put in place. That black drain that I was talking about, that's the surface drain of the floor. You can see the floor is falling. So the floor is falling to a V to this drain. So this is what keeps the whole area clean and where the water disappears to down that drain and away from the area. Again, just to remind you, that's the finished room. So what else is needed, might you say, for the building area, or what do we need to produce? So we need a dry, clean, dust-free room for our compressor. So this is the compressor. Then we have our milk filter. So the milk passes through the milk filter, and from here then it heads off to the dairy. So when it gets to the dairy, in this photograph, we can see our tube cooler. So our tube cooler is that cylinder on the wall. To the right of the tube cooler is our CRS. So the CRS is the communication between the milk tank and between our robot. Also, we need an office. So here we keep our computer, and there's also software licenses associated with the T4C. So the T4C is the farm management software. Next, we talk about the minimum electrical requirements. So you can either have single phase or 3-phase. The requirement for our 2 robots is 7 kilowatt. The compressors are 4 kilowatt, Typically then a bulk tank would be 3.5 kilowatt and a dairy heater would be 3.5 kilowatt as well. So generally farms would be looking to work off about 20 kVA, and this would be single phase supply. Typical power on farm of robot installations would be 20 kVA. Now, some farms are working off 16 kVA, which is fine. More would be greater, 24, 27, 29. It all depends on what other demands are on farm. So you could have a well, you will have an auger system for the supply, you could have scrapers, washdown pumps, or you could have welding going on in a workshop. So this is decided by consideration with your electrician. So here again, in the photograph, we can see our central unit. So this is the central unit that William mentioned earlier on. This incorporates the vacuum pump, water heater, and our chemical pumps. So for Lely and for our installation, we require 3 power supplies, so 3 rotary isolators. So one at the central unit, the second one at the compressor, and the third at the CRS. Inside in the robot rooms, we need a blue 16 amp socket. This is for our service engineers in the future. And with only 3 isolators, you can see that there's a minimum electrical cost required. So water requirements. Water requirements on a robot. So for a single robot, 2 robot, you're looking at approximately 400 to 500 litres a day. So we would have a 1,000 litre storage tank. And the reason for the storage tank is that it gives a break in the water supply. The reason why you need a break in the water supply is because you have chemicals connected and you do not want that to siphon back into your drinking supply. Also, if your water supply was switched off, or if in instances where you have a well, if the well pump broke, you have a reserve. Internet connection is also required for the robot, as is phone reception for technical support. Thank you very much, and we'll lead on to any questions now.
Okay, so thanks very much to Seamus and William. A very comprehensive presentation there. I think we all learned plenty about what's involved in a robotic milking installation, so a lot of valuable lessons for all of us. So without much fuss, we're going to go straight into the questions and answers. I want to introduce Mark O'Farrell, who you haven't met just yet. So Mark works alongside Seamus McDonough. He's one of our project coordinators with his construction background. So once the likes of William or Simon has agreed the big plan concept with the client, Mark will go on farm, survey the site and develop all the detailed drawings, and he'd liaise with the plumber, the electrician, all the different tradespeople. So he's fully responsible until the first cow is milked in the robot. He'd also work closely with our farm management support team. So we're going to head straight into the questions. In case you don't realize, there's a chat facility there on the bottom of your screen. So if you have any questions, text it through. We have a good few already. We'll do our best to get through most of them. And anything we don't get covered this evening, we'll email those who answered and make sure all questions are answered. So the first question, I think, is for you, Mark, is how long does it take to install 2 robots on a Grazeway?
2 robots on a Grazeway, you'd be looking at anywhere up to 4 days. Generally, 1 robot would be 2-3 days. Grazeway itself will take a day, but then 2 robots on a Grazeway, you'd be looking at 4 days on average now.
4 days on average, okay. And a question that might link into that, and it's from Paul. How many times would you be visiting the farm over the course of the project?
Look, it would really depend on the size and the scope of the job, Niall, but I would say on average we're going to be on farm anywhere from 7 to 12 times. We would go out there for a handover after the farm layout has been agreed upon with our yard planner, and then we would carry out a survey of the yard. We'll get a detailed plan together. We're available to meet builders, different contractors, electrician, plumbers, At any point, we're a resource to be used by the farmer or the contractor. And then once the job is there to be installed, we want to make sure that everything is there and done on time, under budget, and within a time frame expected.
Just while you're on there, Mark, what's the sort of biggest areas farmers you get tripped up on? Where do you find the most common mistakes people will make in your experience?
Look, the drawings can be detailed. Sometimes those drawings can be misinterpreted, so it can be beneficial to have us go out, walk the builder or the farmer through it in person. Time frame is something a lot of contractors and farmers can underestimate. Remember, a lot of the work is going to be external, so we're dealing with weather, so we really want to try and do as much work while we can when the weather suits. But yeah, like lining up contractors to get them in one after the other to make sure that the build is done in the time frame expected is one area where we see farmers can sometimes underestimate what's involved.
Very good, very good. Another question from Paul is: Do you look at the farmer's building budget when you were on site? So I suppose that you discussing costs with the farmer before he appoints his builder.
That would be something at the discretion of the farmer. But yeah, look, there can be times where a farmer prior to the job starting would say, this is the spec involved, these are my quotes, and at the moment we've probably done up on 400 robot installs now in Ireland, so we've got a good handle on whether a job is coming in at a reasonable cost. So if a farmer feels comfortable in sharing his quotes with us, it can be beneficial. We might point out something that is an anomaly and say maybe you should get that requoted or ask a question about that. You know, in doing as many robot installs as we have, we've got a good database of contractors who have performed the job in the budget expected, in the time frame, and you know, it's a successful install. So we can recommend any of those contractors to a farmer if need be.
Thanks, Mark. A question, William, for yourself. Can I go check out design if I have 2 robots or less?
You can, yeah, I suppose, you know, the options are, you know, looking at going either head-to-head or a checkout system. So a head-to-head where you know, we saw earlier, they're just sitting just off a tank, or a head-to-head system where they enter from one side of the robots and they're exiting out onto maybe a different area, a different tank on the far side. There's nothing to stop you going with a head-to-head system for smaller numbers. We generally look at it, you know, we don't just look at it as whether head-to-head or checkout. We kind of look at the whole farm and see the number of cows that are on the farm, where the farm is going to go. So, if, you know, they might be starting with 1 robot, but is there scope to go to 3 or 4 down the line if the system works well for them? We'll be looking at, you know, the existing buildings that are in place and whether we can fit, you know, if you can retrofit 2 robots or 1 robot in a head-to-head kind of layout in existing sheds, it might save a lot. I suppose the pluses and minuses to each system. The head-to-head probably has a bigger, you know, can take up a bigger space within a shed. So you want to be looking at that and see how it tie in. But there's nothing to stop you going a head-to-head or a checkout system. It just really depends on, you know, the level of the build you want to go with, the number of cows you're looking at, and I suppose the existing facilities that are already in place on the farm.
Very good. Thanks, William. A question for yourself, Mark, from Robert. Are footprints supplied with robots?
No, it's a question we get often. The footprints are not supplied with the robot. You can get a precast footprint supplied from a manufacturer, but we do supply detailed drawings for a farmer or a builder to bore and create those himself on farm. Can be done at a straightforward and it's very cost efficient.
Very good, very good. Yeah. William, question from Kevin for you. Can robots be fitted on slats?
Yeah, I suppose we'd have a lot of robots that would have, would have been fitted on slats before. A robot itself, the Lely robot is very simple. It can be bolted down to any surface really, slats included. The one thing to be mindful of, if you're going for a grand tonner robot, you can't bolt it straight down onto a slat. So we have had farmers before that have had to, make that kind of a waterproof surface. So, go with a 4 or 5 inch screed of concrete on top of the slat and then put the robot down on top of that. And then there's, I suppose, things to be looked at in terms of drainage and the sump underneath where the cow is standing. But I suppose we have the experience of it that we're able to guide farmers exactly what they need to do to make sure they are compliant with the grant if they are going on top of a slat. You see a lot of the robots on the continents will be bolted down on slats as well. So it is something that has been done plenty. I suppose the big advantage is that it makes that robot room a lot easier to keep clean.
Another one for you, William, from Ailish. What is required for the grant application, and how long does the grant application take to go through?
Well, for the grant application itself, all you really need for a robot is a Farmyard sketch and to know your costings, I suppose, for the robot, and we can help you with that. Apart from that, you don't really need anything else to put in a grant application for a robot. I suppose there's an advantage compared to if you were going to do a slatted shed or a tank or anything like that. You need to have full plan and permission approved before you submit a grant application, whereas with a robot you don't need to have. There is a certain amount of paperwork and certs and paperwork that you need once the robot is installed. But look, we've done a lot of robots with the help of grant aid. Robots have been installed, and we're good at giving out the exact paperwork. That means there's no issues when it comes to a payment claim. The other requirement is just that the robot itself has to be a metre off an open tank when it is installed, or a metre off a slat. So like that, it's putting a screed of concrete around it if it's on a slat, or just stepping it back off a slat. But we've done plenty that we can guide.
There's a question after coming through from Enda. I might try and handle it myself. How does the robot install cost compared to a rotary for a 500 cow herd? We've already had a webinar end on that, on large herd management. So if you look back on our listen back option, you'll have the opportunity to watch that again. And if you have any questions, we'll quite happily answer them if you get in touch. But we have a number of 6 and 5 and 4 robot farms up and running, and more in the pipeline. So in these particular cases, these guys, when they studied the facts and studied the figures, there was very little difference in the total cost between putting in 6 robots and putting in a 50-point rotary. And they felt that it was going to be more sustainable for them long term. It's going to be easier to keep staff. They're going to have more information on their cows. They're going to use an awful lot less water, an awful lot less electricity. And overall, they felt that the maintenance costs would be very, very similar. So, admittedly, it does depend on the spec you're looking at. If you're looking at a fairly decent spec, believe it or not, the robots could come out actually at a lower total investment cost. But I'm more than happy to, if you're interested, to look at a set of plans for your yard and your setup and give you some costings on a large herd project. We have a team called Dairy XL, which is a team that focuses on the larger herds, so we can pull in their experience as well if required. Question from Joe Mark for you: Do robot rooms have to be mass concrete? And what material do you use in the ceilings?
First part of that question, no, the walls do not need to be mass concrete, although many are. In several retrofit applications, the robot room will be placed in a shed where there may not be the access to get in concrete shutters to be able to pour concrete above the shutters into the walls. So in that scenario, we've seen blocks been laid on the flat. Only difference being that the walls would have to be plastered inside and out to get that wipeable surface that is required. With the ceilings, 3 main types of ceiling we're seeing installed. It would be a hollow core concrete placed on top of the walls, then an insulated panel or a Kingspan sheeting with a metal sheet either side, and then finally you would have your traditional wooden joists, plywood on the top, and then PVCs on the underside.
Okay, thanks very much for that, Mark. Another question from you is from John. Have you any recommended list of suppliers? Hard to get good builders in my area. So yeah, I think that's the gist of it. Have you a list of have you a recommended list of suppliers? That's for you, Mark.
Yeah, look, farmers are free to go out and get their own contractors, but as touched on there in that question, it is hard to get a good contractor in the time frame that you'd like to get them in. So having worked on a lot of robot installs here at Lely Mullingar, we do have a list of contractors who have performed an install in time frame expected, budget expectations, and everything is ready to go when the robot comes. So when we're, if ever a farmer wants a competing bid or wants access to that, all he has to do is call us, one of us here at the office in Mullingar.
A question for William is, how long, I suppose for both of you, William and Mark, what is the fastest turnaround for a robot install? And it's the same question from someone else. What's the fastest turnaround from greenfield site to ready to take? So I suppose, William, what's the sort of, in your experience, Mark, jump in as you wish, how long is it taking guys typically from say, when we get the thumbs up of an order to have the system ready to roll?
I suppose generally you're looking for a farmer maybe to give himself 4 to maybe 6 months of a lead in to do, the groundwork, the building work, everything like that, if he is looking at a greenfield site. Now look, we've had farmers before that have had a lot quicker of a turnaround for greenfield sites. We've one farmer there who did a 96 cubicle shed and 3 robots. He had other existing cubicle sheds as well, but that was a greenfield site and he got that done in about 6 to 8 weeks. So that was a very quick turnaround. Another one there, 2 robot greenfield site, started it there the 29th of November last year, and again he had that done in about 2.5 months. So for the greenfield sites, that's on the quicker side of things, but it is achievable, and we have seen it done. I suppose with those type of systems, with those type of turnaround, you really need the project coordinator. That's where they get their full value, because you need them out on site pretty much every week throughout that build, because there's so many things changing and the builder is moving from one thing to the other very quickly. So you just need to keep on top of it and make sure everything is being done at the right step. I suppose when it comes to retrofit, to physically build the robot room itself, if you had a builder on site for a week, 2 weeks, you'd have most of the work done for the actual robot room itself. So there can be a very, very quick turnaround when it comes to building a robot room. But like that, having the detailed drawings that the builder can work off, it means that he's doing it and he's doing it right the first time, and there's no need to come back with consoles or, gaps aren't big enough or gaps are too big. So it's just having that infrastructure in place that things are done correctly. We've seen farmers before who could have built the robot room in a couple of weeks, and then they're done. So it very much varies.
We've had examples of guys who, between making the decision and getting milk in less than 2 months, with even greenfield sites. So it's amazing what can be done if you have a good team of people around you and you get a bit of weather. Yeah,
and I was just going to add there, Niall. I mean, there's one farmer I worked with last year. Now, I went out one evening, we marked out the location of the robot walls, and that evening he broke out the concrete and had his builder in the next day pouring footings for the clean room walls. And I mean, he had the ceiling on within 2 weeks and ready for electricians to start running wires. So when the conditions suit and the farmer is motivated, a lot can be done in a short space of time.
Very good. And I've often seen instances where a client is putting in an additional robot, and that can be put in a day if needs be. There's enough men on site. So as I say, when you're organized, it's amazing what you can do. So what else have we got here? I'm just looking at the same questions. Is it expensive to move robots? This is from Enda. Thinking of installing in old buildings, but might build a new shed in the future. I might answer that one, lads. So we've examples every year where a client might install robots. It could be new entrants. Sometimes they might say, look, we want to make use of these existing sheds, but if this project works well, the long-term plan might be to build a new greenfield facility, or it might be to put on a serious extension. So one particular client in Meath comes to mind, put in 2 robots, one either side of a central passageway, studded walls, outdoor milk tank, precast cubicles, very simple setup, grass-based system, worked really well. 3 years down the line, decided then to build a new greenfield site. So we got our yard designer Simon on site with the client. They designed a 200 cow cubicle shed with space for 4 robots, and then that client put in a 3rd robot. So we they were never left unable to milk. We were able to set up the new robot in the new shed and then move the 2 existing robots into the new shed. So the client never was unable to milk cows the way we set it up. And there's the scope there for a 4th robot, which may happen in the future. Another client in Lely, Gwen and Trevor, they started with 1 robot in an old beef shed, bedded on straw for a number of years, installed a 2nd robot in that straw shed, and then maybe after 4 or 5 years, can't remember exactly, they built a fabulous new 200 cow cubicle shed, put in a 3rd robot, and just this year now put in the 4th robot. So from new entrant to, you know, not a million miles off, 300 cows in probably 6 years, but started off making use of existing sheds and bedding on straw. So it's great to be part of that journey. So we've huge experience in moving robots, and I can actually see more of it in the future. So it's not a huge expense if we plan it properly and we know putting it in, there might be an option of moving them in the future. So it is something I can see happening more in the future. There's a question here from Jerry. How many cows can I milk in a robot? Jerry, we probably won't get into that now because we looked at it before. 70 is the most common number. But we've had a number of webinars on cow management and all that type of stuff. So I'll send you some links and you can see those particular webinars. A question for William. How can I find out what power supply I have, and how long do ESB upgrades take? And that's from Seamus.
I suppose to find out the power supply you have, you're probably looking at getting an electrician out to do a survey of the yard. You know, generally we get a lot of questions as, you know, what power supply do I need, or do I need 3-phase? Do I need single phase? Do I need certain power? We've seen, you know, up on 4 robots could potentially work on a single phase farm with up on 29 kVA. But it really depends on what else you're going to have pulling out on the farm when you get to that numbers. You know, if you're up on 4 robots, you could be near 300 cows. So you're looking at what else is there. You know, if you have the likes of a robotic scraper, they can be a lot more energy efficient than, say, you had 6 or 7 hydraulic scrapers working in a yard. So, you know, it just really depends on what else you have in the yard. But you're probably looking at getting an electrician out to test the supply that's there. But whether it's single phase or 3-phase, it doesn't matter for us. The robot can be ordered depending on which you have. I suppose, Mark, you probably have more experience on the length of time it takes for the ESB upgrade, so I might let you feel that.
Yeah, I mean, look, really, when we get to the farm, we'd be asking that the farmer find out the power supply almost right away. If he does need to go for a power upgrade, you cannot contact ESB quick enough. Generally, we're seeing turnaround time of about 3 months from them. And look, with COVID-19 this year, that time frame is even a little bit further. So I would contact the ESB as soon as possible, have them discuss options with you. It may be the case that there's both single phase and 3-phase available to you. They'll give costing on both and help you make an educated decision on which one works best for you.
I suppose no harm mentioning there as well that in the vast majority of cases, the current power supply that's on farm is generally more than sufficient to go with 2 robots, your bulk tank. You know, for a new entrant, from what we've seen in the vast majority of cases, what the power supply that farmers have on farm is usually adequate.
Yeah, look, I'm only going to take 3 more questions, lads, and we'll wind it up. One question here that may have been covered already. Do I need 3-phase for a robotic milking system? Short answer is you don't, and I think the lads have mentioned it already. You can have up to 4 robots on single phase. How many robots can you have on the one site? I can't remember exactly what is in other countries. The biggest we have on one site, a Lely Mullingar client, is 6. There's a client in the north of Ireland. I think there's 12 or 13, maybe more. There's some farms elsewhere in the world with, I believe, I think about 70 robots. I could stand corrected on that, but I know there's 50 plus on sites in different countries. But the biggest, we kind of just work off our own experience with most of our clients being spring calving, grass based. So 6 robot farms we have up and running and working really well. So that's the biggest we have, and that with scope to increase as well. And we don't see any issue with 8 robots in a spring calving grass based system. Like, we see plenty of scope for at least that. Can you have robots on multiple sites? I leave that as the last question. I'll try to take that as well. Yeah, we just after finishing a job in Meath for a client who's after, he's well established robot farm, doing an excellent job. But what he's doing is he's after leasing a farm. We've installed 2 robots on this lease farm, so I'm assuming it's a 10 to 15-year lease. He's going to do autumn calving on that farm. So he's got, say, the guts of 300 cows in his main farm, spring calving, and then he'll use the same, himself and the same lads that work with him. Then we'll look after the autumn calving herd that'll be calving in September. So their routine will be, they'll do what they have to do on the main farm, and then after their breakfast they'll tip down and do what they need to do on the second farm. So we can see a huge increase in the interest in customers and new customers looking to grow their business by installing robots on second blocks. Some of these people already have parlours, they're up and running, they're established, they're happy enough with what they have there, but they may have 70 to 140 cows on another block milked by 2 Lely robots. So we've a number of those installs happening in the next few months, and a good few of them in the pipeline for next year. So we're looking forward to that. So I think we'll leave it there, folks. I want to thank William. I want to thank Seamus for their excellent presentation. I want to thank Mark O'Farrell, part of our project coordination team, for joining for the question and answers. This webinar will be up on our Listen Back facility in the next few days. You should all receive an email, and there'll be 10 webinars there in total at the moment, and we'll be adding more over the next 6 months. So thank you very much for your interest. Feel free to contact the team here at Lely Centre Mullingar if you have any other questions that we haven't answered, and we'd be delighted to talk to you. Thank you very much.